Hopefully you've had a chance to try this problem yourself. We're going to go through the solutions now. So I have a list of 4 different molecules or compounds, and we're going to try to identify them as either covalent or ionic. So let's go through and first just apply our generalized rule that if it's metal, nonmetal, it's likely to be ionic. And if it's nonmetal, nonmetal, it's likely to be covalent. So in the first one, we have calcium and fluorine. So calcium is my metal and fluorine is a nonmetal. And so I'm gonna guess that this is ionic. Sorry. All right, looking at my next one, I have carbon and chlorine. These are both classified as nonmetals. So I'm going to assume this is covalent. All right, next up, I have sodium and oxygen and hydrogen. Sodium is a metal. Oxygen and hydrogen are nonmetals. I'm going to guess that it's ionic. But that OH, that would actually be a covalent a covalent polyatomic ion. Because they're both nonmetals. All right, next one. I have NH4NO3. These are all nonmetals. So I might say it's covalent. Looking at this, and this one's thrown in here to be a little bit tricky. Looking at this, though, the way it's written is providing a hint. The nitrogens are not grouped together at all. Like it doesn't say N subscript 2. And what this chemical formula is doing is trying to provide, the hint that we're actually looking at 2 polyatomic ions. This doesn't happen often because we don't have a lot of cation polyatomic ions. NH4 plus is one, H3O plus is the other. That's common. And so really what this is an NH4 plus polyatomic ion and an NO3 nitrate, NO3 minus polyatomic anion. And so each of these are covalently bonded within the polyatomic ion. But when they come together, they're 2 charged molecules and they'll form an ionic bond. Right? And so this one's kind of our special exception in these. Now for my 3 before it that are a little bit more straightforward, I'd like to go back and double check their electronegativities. So calcium and fluorine, let's make sure this is really an ionic compound. So calcium has an electronegativity that I'm pulling from the chart we showed earlier of 1.0, and fluorine has an electronegativity, I'll do it over here, of 4.0. So the electronegativity difference between these two is 3.0. All right, that's greater than 2.0, so that supports my ionic assignment. All right, carbon and chlorine. So carbon has an electronegativity of 2.5. Chlorine has an electronegativity of 3.0. The difference between these two then is 0.5. And so that falls in that 0.5 to 1.9 range. So this is covalent, but I would actually call it a polar covalent bond. All right, last up, sodium hydroxide. And that's going to be bonding to oxygen and hydrogen as a polyatomic ion. So that's going to be a little hard to determine if a comparison of electronegativities, because we're talking about a polyatomic ion. Now, just because I know this, I know that it's the oxygen that's carrying most of the negative charge, and will be actually interacting the most with the positive charge on the sodium. And that's based on the electronegativity between the oxygen and the hydrogen. The oxygen's more electronegative. So just to kind of by way of example, I'm just going to compare the electronegativity between my sodium and oxygen, even though this isn't a really accurate way to do it because it's not oxygen alone, it's oxygen bonded to a hydrogen. But my sodium would be a 0.9 and my oxygen would be 3.5. And so this is going to give me something around 2.6, right, for my electronegativity difference. So that would support an ionic bond anyway.